Going to be from VincentLo from Asbill, North America. So come on up, and Vincent's bio is extremely verbose, so I'll read it to you here. Vincent works at Asbill, where they develop control solutions for a range of clients. His focus is geared towards system-level automation for semiconductor processing, alternative energy, and earthquake safety. VincentLo.
Thank you all. I'm going to keep it nice and short tonight. So, what I want to introduce tonight is an earthquake detection system that's currently commercially available, and it's really geared for what I call critical shutdown or automated control. A little bit about myself. I think, again, business development for Asbill. But one of the things that we didn't cover tonight really is what is the core function of this earthquake management system that we provide. Really is to prevent fires. I think fire damage actually accounts for majority of the assets damage, according to what we believe. This is a image of course, the great earthquake of 1906, in which the city of San Francisco really burned for 3 days. Here on the upper right-hand corner, we have a chemical plant and also an oil refinery that really burned after an earthquake. So again, really just to prevent broken gas line, power lines, and fuel stations. So what does a intelligent earthquake management system consist of? A sensor product, a sensor device, really based off a 3-axis accelerometer. There's a lot of waveform recording, analysis done on the back end. Also a data acquisition system that that's used for collecting the data, having a sequence of control shutdown, whether it be a gas line valve or an oil valve or some kind of warning system, and also acts as some kind of active recovery system. And then the last part of it is really just data management, where the data goes to a control center, and operators can monitor what the conditions are. They can do manual override if needed, and once everything looks good, there's no leaks or anything, we can initiate an active recovery system, an active recovery process in which pretty much we just give gas to people so they can have hot water and have run their furnace at home. So the use case in Japan, over 20 years ago, we started collaborating with Tokyo Gas and the local Japanese government to develop this earthquake management system. And it started off with a couple of hundred of sensor systems in the greater Tokyo area to what it is today, which is about 4,000 units installed at a very dense area, all acting independently with their own control system, automated control system for shutdown as well as recovery. And in the Great East Japan earthquake back in 2011, our sensor system was able to shut down all the critical gas lines without shutting those that aren't as critical, leaving them operated so people, again, could have hot water and heat. So how does our system work? We pretty much overlay the geological survey of the area along with the sensor systems that are put in place. And with that, we tune each system according to, again, according to the geological makeup of that area. So again, we can tune for specific shutdown intensity. We can check for liquefaction risk. And also in areas where we know we might lose communication, we actually have redundant system in place. So why is this important for wireless sake? Right now our customers are looking at being able to communicate to this device using remote access. Being the device is a lot of times buried in areas deep and close to the assets, it's hard to get to. So one of the areas we're looking at is being able to communicate to it via Bluetooth or Wi-Fi and do simple configuration, run diagnostic, make sure everything is good, and export some data in terms of like recording the waveform, export that data. So that's one of the use case we're looking at now. The second use case in which we're really trying to implement here, along with the local utility, is a system, what we call sort of a hybrid control, where the earthquake detection system, it's going to automatically perform its critical shutdown sequence based upon the seismic intensity. But at the same time, we want to be able to, again, access the data that's stored inside the device via cellular network, or potentially through other kinds of Zigbee or mesh network. And to just give you an understanding of the scale between California and Japan, Japan, it's about the size of California, but in terms of the Tokyo area, the population is equivalent to all the population in California. So imagine everybody in California squeezed in really just about the Bay Area is how dense Tokyo is. So this kind of system really works for high-density residential area. That being said, one of the key things is, as built, we're really big on earthquake safety. So each of our employees, we have our own hard hat in place underneath their desk, so that if there's an earthquake, they can put it on. We have food stored for 600 people that can last for a week. And within our own facilities, we have our own earthquake detection system where, again, if there's an earthquake, we'll have we'll shut everything down. That's critical. We'll broadcast a variety of safety instructions on what to do, keep everybody moving in the right direction. I think that's actually it. Oh, this is just okay. Thank you.
Okay, very good. Thank you, Vincent. So our last speaker is Paul McBurney, and Paul McBurney happens to be not